Today we are learning about antidifferentiation. So we know at this point how to find derivatives. For example, we know that the derivative of x cubed is 3x squared. But also notice that the derivative of x cubed plus 5 is also 3x squared. And that's going to be true if we take the derivative of x cubed plus or minus any constant. We'll do the last one here, x cubed, let's make it minus pi, will also be 3x squared. Now if we talk about the antiderivative, what we're really doing is the opposite. We're looking for the function whose derivative is, for example, 3x squared. So the antiderivative is like asking what function has a derivative of 3x squared. So we know that this question has many answers. We could say that it's x cubed. We could say that the antiderivative is x cubed plus 5, or x cubed minus e, or x cubed minus pi. But we know that there are infinitely many responses to this type of question. So what we do is we write this as x cubed plus some constant c. And that will cover the infinitely many possibilities for what c might be equal to. So how do we notate the antiderivative? Well, let's write this out. We're going to say that the antiderivative of 3x squared is x cubed plus any constant c. The way we write that in symbols is we use this kind of elongated S. And we sandwich our function. Right, we're looking for the antiderivative of 3x squared, so 3x squared goes here. We put this in between our elongated S and our dx. And this is here because when we take a derivative, remember it's with respect to a certain variable. So here we're taking the antiderivative again with respect to x. So this is equal to x cubed plus c. Okay, now that we've got the notation, let's get a little vocabulary going. This whole expression here is what we call the indefinite integral. There is a definite integral, and we'll talk about that some other time, but this one here is our indefinite integral. And this c is called the constant of integration. So we may come across something like this, the integral of cosine. So what this is asking us to find is the antiderivative of cosine. So you ask yourself, what function has a derivative of cosine? And our response is that would be sine, but it could be sine plus or minus any constant. So we put our plus c where c could represent any real number.